All right. Good day, everyone. Welcome to day three of our lesson one, machine learning fundamentals, preparing your professional machine learning engineer journey. So from the very first day, we've already gone through the basics of machine learning, what is AI, different supervised learning models and unsupervised
हाँ
models.
हाँ हाँ
Please unmute yourself, please. Please mute yourself if you.
हाँ
Sorry, I'll just mute everyone now. All right, so I just want to mute everyone. So we've talked about supervised and unsupervised learning. We've talked about different categories in the supervised learning, the classification and regression, then unsupervised learning. We looked at neural networks. Yeah, we also looked at activation functions. Please refer to the previous videos, day one, day two for this. We're still going to touch them later on in future, but just so that you know, we've visited this in day one and day two already. This from day two, we visited loss function. We talked about loss function. So when you're doing regression, the loss function to use, the loss function for classification problems, right? We also explained backpropagation, gradient descent, right? So some of these concepts we're still going to look at it and talk about weight bias, learning rate. So without wasting much time, we shall jump to this is where we are going to start today. All right, so let's explain this concept of area under the curve. All right, it's of course when it's a matrix. Remember, we've looked at precision recall. These are metrics for evaluating your model. And there are different times when some of them are very much important or are very much needful, useful than the rest. So there are a lot of metrics involved, but today we're going to be looking at area under the curve. And so this area under the curve is built with there's what we call the receiver operating characteristics, whereby so normally you would have your confusion matrix and for a certain threshold, right? So you want to observe how your model behaves across different thresholds. Now your threshold could be maybe let me go back to this diagram here just for explanation, right? So let's say you want to predict whether something is whether you want to predict whether it's a fish or rock. You have this model under the sea, but you want to be able to detect fishes, and then you want to also know whether it's catch fishes, detect fish. All right. So at certain point, your model could your model could use a certain threshold to make a decision. So there's what we call decision boundaries, where you have this straight line, and then anything that falls outside it says whether it's a fish. Anything that falls within this boundary says whether it's a rock or not. Or you want to say, well, there's a probability that if this is if the probability is 50 or 0.5, then you want to decide that this is a fish, or you want to decide that this is a rock. You can also say that the threshold should be 90, all right? But when you're deciding those threshold, at each threshold, you might not be able to to classify some of the things correctly. All right. So in this case, when we don't have you're not sure of the threshold to use, but once you know how your model, you want to compare how the different models you've trained have performed over time, you have to use area under the curve to visualize that. All right. So in this case, you're going to be picking a random positive and random negative point. So what's the probability that your model scores them correctly in relative order? So that's what area under the curve does. And yes, now this brings us to this concept of let's look at the concept of underfitting, overfitting, model underfitting and overfitting. So in some cases, the model is so simple that it misses a lot of data points. It's so simple. You can see it's a very linear model and very simple, but it's not able to generalize. It's not able to um, classify things appropriately. It's missing a lot of points. All right. So this, well, when we say that the model is what the model is underfitting, and then in some cases we have what we call the model is overfitting. The model has learned everything, both the noise. You could see this line going, the blue line is able to learn a whole lot of the noise, the data points. In fact, it's just like in the exam hall when you're being trained to learn, um, you're being taught to learn, understand the topic instead of memorizing the answer. So in this case, memorizing every data point here. And so the model was overfit. So if you were preparing for an examination and you memorize the answers without understanding the topic, if you're given a new topic or a new question, which you've not seen the answer, you would fail that exam. And that's what overfitting does. All right. And then there's a balance between this underfitting and there's a balance between where the model underfits and where the model overfits. So you have which is the balance. So moderation is key here. You could see it fits, it tries to understand the patterns, you know, but this one tries to understand everything, put the noise, put the outliers. All right, so do we have any question at this point? Does anyone have any contribution to make at this point? So here the model is what too simple. It cannot capture true relationship on the fitted model, right? And so it's just like trying to draw a curve using a straight line, using a straight ruler. That's what's happening here. It won't fit well. Well, here you have a good fit model. The model captures the overall pattern without worrying about every simple fluctuation. All right, the model is capturing the overall pattern here. And so this is the right level of complexity. All right, it's capturing the true signal and is ignoring the noise, capturing the true signal, just very good fit. So this will perform very well on both the training and on scene data. All right, so very good. You're drawing here, we're drawing a smooth curve that follows the general shape of the data. And that's what happens here. And then overfitting here on the right, you see that the model is what? Too complex. It's too complex that it tries to fit every single data point. All right. And then this means that the model is too It's too complex, and then it will give us a very high test error. This will give us poor generalization. Um, yes, so that's what happens here. So at the point of training, it gives you this false sense of success. So everything works on that when doing training. But when you're testing the model, it fails. All right. So that's what happens. So later on, we're going to be looking at ways to avoid overfitting. There are different ways we could avoid overfitting. There are different approaches. You see some people doing the train test split, train validation test split. You could see regularization. You could see cross validation, early stopping. There are different approaches to avoid what overfitting. And so this is what's going to lead us. So this is one of the very approach. Um, in order to avoid overfitting, the very first thing you need to do is to do what? So have your data set. This is your data set, your general data set. You're going to have your training and your test set. Now, this is your training set. This one we call experimental. Is your training set. All right. Your training set is now divided into this data set right now is divided into training and validation one set. At the end of the day, you're going to have training, validation, and what? Test sets. All right. So this is what you're going to use for training your data. You can see it multiple times. Use this for validation, use this for hyperparameter tuning. And then the test set should be used only once to evaluate the final model. So this should not be used during training and validation. So this is an approach that is advisable, an approach that you should follow as machine learning engineers, as data scientists. All right. So test data must be very much independent. It should not be seen, should not be used for training. It shouldn't be used for tuning. All right. So you use this to do or to evaluate real world performance. So now what do you use for your training? This. So remember your entire data sets, keep a portion of it for experimentation, which you're going to divide into training and validation data. All right. Now, during training is when the model is what? Adjusting its weights, adjusting its parameters. So this is the data the model will use to do what? Adjust the weights and parameters. All right. This is the data set the model will use to fit the model fits, yeah, this is used to fit the model patterns in data in the training sets. And then the validation set is what you use to make decisions about the model. So use it for you've finished training the model, but you're looking at it, you want to improve, you want to see if it's better than. So you can tune the hyperparameters, choose model complexity. Yeah. All right. You can also decide when to stop training, use it to compare models, validation set. All right. Then your test sets should be what? Final, used for the final evaluation, unbiased evaluation. So use it to do what? Estimate performance on what? New and unseen data. So any question at this point before we proceed? You can unmute yourself or write it in the chat, please. Please, if you're hearing, let me let me see thumbs up if you're hearing what I'm saying. I want to be sure that people are still following. Hello?
Yeah, I can hear you, or we can hear you.
Good, good, good. All right. So now, um, who have heard of this concept of cross validation? If you've trained, if you used cross validation before, can you give us, tell us what is it, what you did it for, how it works?
Okay. For my own understanding, I've used it before. I'm
Okay.
I'm not that conversant with it, but I know that it's used to like when you're training a data set to get the most efficient um data, use cross validation. Like it's going to how can I put it? I'm out of words.
Okay, don't worry, I'm gonna help you. Yes. Who else have used it? Thank you for your contribution. Yes, who else want to say something? All right, cross validation, So we've already talked about having your training and validation set, right? Now, but you don't want to just rely on the training data alone. So what do? You want to give you want to reuse your data set multiple times. Now, for you to do that, you want to split this training into maybe 5 parts, K folds, K number of times. Maybe you want to split it into five parts. The training data, you can split it into five. Now, each so what happens is we split the data sets into multiple times, and each time with a different part, each part is held out for validation. So if you split this into five, 1, 2, 3, 4, 5, at the first run, um, one of the every data point gets a chance to be the training data and a chance to be a validation part. Now, so we can have the one validation set, and then the other part of the data set will be what? Training. Do you understand? We can split the data set, this training into 5 parts, but keep one part for validation. You're still doing training, all right? But then alternatively, we're going to be each part of the data set, there's a repeated process. One fold is used for validation, and then the remaining part is used for for training. The remaining fold. So you have multiple folds of the same data set, of the same training set, and then one part is so we can keep one part, use the remaining four for training, come back again, choose another part again, and use the second fold for validation, and then use the rest for training. Come back again, use the third fold for validation, use the other part for training. So each data set would have a chance to be used for training and validation. So now let me give you a simple scenario here. So for instance, now I'm training you for an exam, right? And instead of giving you one test for exam, and some people just write a test and they are very lucky because the questions that came out are the questions they read. And this can also happen when you're training machine learning models. So you could be lucky that, it could just be mere luck that the data set that came out during the testing was the one that is already, somehow is able to identify those patterns. All right. But then when each of the data set gets chance to be used at training and validation. So in this case now, I will not give you just one test to give you your exam score. I will give you what? 5 tests, 5 different tests. So you're going to write your first test. I'll take the score. I'll keep the score. I'll give you, you take your second test score, your third, fourth, fifth. Now, instead of taking one score, I'll take the average. This is just an example, just for you to understand. All right. I'll take the average. And then, so the whole evaluation is not just done on one test. All right. I'm able to evaluate you on what different. So for on each of these tests, I'm changing the questions. I'm changing what the question. So you won't see the first. You might score the first test. You might be lucky in the first one, first two, first three, but you might not be lucky in the last one. So you'll be forced to do what? To read what? All possible questions. So and this is more comprehensive. This is more detailed. So it's more reliable because it's less dependent on one lucky or unlucky split, right? And then is good for detecting overfitting. It makes better use of what? Limited data, cross-validation. So that's why we use cross-validation. All right. So you can also use it for model comparison, hyperparameter tuning too. All right. And yes. So any question before we look at the next concept. So do anyone have any question at this point? So there are some times that you might want to look at the model complexity when calculating error. So you might want to aim for a low training error, and then or you want to balance against complexity. So there's this trade-off between is this model complex? No, the more complex it is, it might be data dependent. So you might just want to have a balance. There's this trade-off you might have to be looking at when you're doing hyperparameter tuning. So when you're adding more layers, when you're making your model more complex, you might try to avoid what overfitting. But you eventually you have to be looking for that optimal model, you know, that balance between aiming for low training error and then balancing your model against complexity. So this leads us to this point where we have regularization. Remember, we are still talking about how to, it's still one of the techniques to avoid what? Over what? Fitting. So you can see there's early stopping, parameter norm penalties. So under this technique, that's why you have this L1 regularization and the L2 regularization. Right, so it's a very major field. That's regularization, a major field in ML research, and so a very topic that's a whole research area in machine learning. Very important that we have it as a research area. Now, in simple terms, we might decide to stop a model from trying too hard to fit the training data. That's early stopping. All right. So, and yes. And then in some cases, we need what we call regularization. Because if we don't apply regularization, the model can do what? Memorize a lot of noise. It can learn so well that it will memorize all the noise. And then we will get a very low training error because it has memorized all the noise, but we're going to have a poor performance on unseen data. So regularization helps us to do what? Control the model, what? Complexity. You don't want your model to learn too much that it becomes understands all the noise, it learns all the noise, and then it will not be able to generalize to when given unseen data. All right, so now we're looking at L1 and L2 regularization, which is part of the parameter norm penalties. So in this case, what happens? The idea here is that we might need to add an extra term to the loss function. Loss function is you want to know how far is the model away from the target, the model prediction from the target. All right, so there's a technique to do what? Penalize large model weights. So when the weight is too far away from the target, we penalize it and then encourage simpler models. So there's a technique that does that. So where you have the original loss and then you add a penalty to the model weight. All right, so but then you have L1 and L2. The difference between L1 and L2 is L2 penalizes square of the weights. Penalizes square of the weights. So the idea is it encourages small and smooth weights and does not usually force weights to zero and then spread importance across features. That's for the L2. The L2 regularization, which does what? Penalizes the square of the weights. So when it does that, it's able to do what? Reduce what? Overfitting, and then makes the model more simple. While the L1 penalizes the absolute value of the weights. So in L1, there are some points where the model weight is set to what? Zero, so that avoids, it just sets it to zero. And then it performs feature selection automatically. So this makes the model what? Very simpler, more interpretable, all right? And this is also very useful when many features are irrelevant. So it sets some weight to zero. L1 does that. L2 tends to shrink all the weights, all right? And L2 gives you smooth models, and then yeah, L1, when you have a lot of sparse good for sparse models. All right, so this is just technique for what? To reduce overfitting. So just have that in mind. Yes. So remember this, we have this slide from 1 to this 54. Now what we'll do is we're going to go through the sample questions, and then with the remaining time left, we're going to jump into the lab so that those that are struggling to start with the labs will do that. So we'll just go through these sample questions and then try to answer them. If you're just starting out, you might not understand everything, but just know that these are opportunities to learn, unlearn, relearn. You might just hear some things for the first time, but just take note of it. So now our very first question is, please, you just drop your answer on the chat, what you feel. You can also unmute yourself. Now you're working on a binary classification machine learning algorithm that detects whether an image is classified, whether an image of a classified scan document contains a company logo. Now, in the data set, 96% of examples do not have the logo. So the data set is skewed. All right, 96% do not have the logo. Data set is skewed. Which metric will you use? So this is a matrix to give you the most confidence in your model. Which metrics will you use? There are different metrics: precision, recall, root mean square error, F1 score error. All right, so which metrics will you use? Can we start by, okay, yes, those that are experts already, professionals, please give us the answer first before we go down to start explaining what is precision, what is recall, what is root mean square error, all right, and what is F1 score. Yes, I want the answers on the chat, please. Can I see answers? Okay, let me look at the charts. Hello, are we here?
Yes, we are here.
Okay. So, what do you think? Not sure if it's A or B. Who is sure? Who has an idea? Who has done if you trained the machine learning model before and you've used precision metric before, you could say something. You could just make a guess and tell us why. You can unmute yourself. Anyone? Okay, so first of all, I haven't gotten to this part yet. Okay. Um, okay, let's explain the first thing. So first thing is, first thing first, we understand that the data, yeah, we're dealing with an unbalanced data set, right? Unbalanced data set. 90% of the examples have logo. And so you remember you're training your data set, you have labels. You have your, let's say we are training something to be cat and dog, right? To understand cat and dog. Imagine 90%, 96% is cat. The other one is only for a dog. It's very unbalanced, right? So you cannot use, there are some metrics you cannot use here that will not be good. So if you're talking about the accuracy of the model, it will not give you the right thing because um, the model would tend towards predicting a whole lot of things as not um, of the other class that is more dominant. So when you're training your model, you have to be very aware of the percentage of classes. Is your data set balanced or not? All right, so in this case, 90% of the images do not have logo. Only 4% are positive. Now the data set is what? Highly what? Imbalanced. Now, the question here is which metrics would you give the most, will give you the most confidence in your model, right? Now, roots, let's start with this. Roots mean square error is a regression metric. It's used for regression when you're predicting values like age, house prices. All right, so this is out of the question. All right, because the problem here we are dealing with is a classification problem. All right, then, so C is definitely wrong. Now, the next thing is, so with 96% negative that don't have the logo, the model will always predict no logo because, you know, if you train it on, I mean, 96%, it's biased already. I mean, it's to tend towards no logo. It always predict. So you might get 96% accuracy. So Accuracy will be a no-no to use here. All right. Accuracy will not be a good metric to test the quality of your model because your model will predict 96% accuracy. And then detect zero logos. Okay. So accuracy will be meaningless here. Now let's look at another option. Precision. What's precision? Precision tells you when the model says that it has logo, it's looking at the positives, right? How often is it correct? That's precision. When a model says that it has what logo, how often is it correct? That's precision. So this is very good if false positive is very what costly. Now false positive in the sense that that if it's predicting something wrong, then it will be very expensive. Now let me give you an example of false positive. False positive is let's say you have this finance team. Let's say for instance the finance team. Let's say for instance you're doing a transaction and you want to transfer money, just $5,000, $5,000, 5,000 naira, 5,000 the currency. And then the AI is saying that you are a scammer. You'll be angry because that's what false positive. You're doing a legit transaction, but the AI is saying this is fraud. All right. So what happens? In this case, false positive is what? It's very expensive. So you want to get high precision. You don't want to deny people legitimate customers that are doing legit transaction the opportunity to use the system. All right. So in that case, you go for what? Precision. You want to make sure that the precision is very high. Do you understand? In this case, you use precision whereby false positive is what? Very costly. All right. Good. Now, but there's a problem. In this case, because of the skewed data set, the model may predict the logo only once. It may be correct once, all right, and then miss miss almost all the logos. Because your precision might be 100%, it might just be correct once, because the data is already skewed. So this might not be a good option too. A will not also be a good option. Now, what is recall? How does recall work here? Recall is out of all the real logos, how many did we find? All right. Now, recall will be very good if missing a logo is very bad. Now let me give you another scenario where recall is used. So in medical diagnosis, let's say for instance, if they are using AI to predict if you have cancer, breast cancer or not. Let's say AI is what the doctor is using. And then the machine fails to predict that you have what? Breast cancer. You know that the cost is very high. It's very bad, right? But then let's assume you don't have cancer and the AI says you have cancer and you're being treated as someone that has cancer. I mean, yes, but it's not so expensive as someone that has cancer and was not treated. Do you understand here now? So in this case, if missing a positive is very bad, then you have to go for what? Recall. All right. So, but then there's no silver bullet here at this point. because the model could what label everything as logo at this point, because if the data is skewed, everything could be labeled as logo. And then your recall rate will be what, 100%, because it's not missing. Or you say everything is breast cancer, breast cancer, breast cancer. I mean, everybody cannot have breast cancer. So in order not for it to miss a breast cancer, it now labels everybody as having breast cancer. And everybody will now be treated as having breast cancer. No. All right. So in this case, um, recall alone is not good enough. So this leaves us with one option, D. Now, what does F1 score? F1 score combines precision and recall. It combines these two metrics. All right. So F1 score it tries to the precision multiplied by recall all over precision plus recall. It just combines the two metrics, and then it ignores the true positives, true negatives, which dominate the data. You know, in this case, true negative is what? True negative is what dominating the data set. So it tries to ignore the true negative dominating the data set. It focuses more on the performance of the minority, the logo class. Yes, it's the minority is the logo class, the company logo, which is minority. And then it penalizes models that gain precision, that focus on recall and precision alone. So F1 score is what you use when you have a skewed or highly imbalanced data set. All right. You might not understand this now, but just have it in the back of your head. All right. You're going to understand this later if you don't do that now. Any question at this point before we move to the next question? Yeah. Did anyone get it correctly? We are all learning. We are all learning. We are all learning. We are all learning. All right. So next question. Good. So the next question is, you work for a retail company. You have a managed tabular data set on Vertex AI that contains sales data from 3 different stores. Data set includes several features, such as store name and sale timestamp. You want to use the data to train a model that makes sales prediction for a new store that will open soon. You need to split the data between the training, validation, and test set. Which approach would you use to split the data? Remember, you want to train this model. You're working for a retail company. You're just been employed as a data scientist, and you have this managed tabular data set on Vertex AI. Let me explain. Vertex AI is Google's platform that provides an all-in-one interface for your end-to-end machine learning. It's a platform that's for machine learning. You can do data training, from data, ingesting data, to your training the model, to serving the model and deploying it. You can also do model deployment on Vertex AI. So that's what Vertex AI is. You're still going to see that later on, but just this is a platform, right? So you have a managed data set. In Vertex AI, you can create managed data set and custom data sets. Custom data set, in this case, you want to use your any data set, right? Manage data sets. You want to have this on Vertex AI. All right. Yeah. Um, and then so remember, this data set is a sales data from 3 different stores. Store names, the timestamp. And you want to use this to make sales prediction for a what? A new store that will do what? Open soon. Now, what will you use? Which kind of split? Don't be worried about this word, Vertex AI. Focus on the kind of split you want to use. Is it a manual split using the store name? What would be important to you? The store name feature to assign. Okay, will you split the data using the store name feature to assign one store for each set? Or will you use the data? There's a default data split on Vertex AI. And then will you do a chronological split and specify the timestamp feature as a time variable? Or will you just do the random split? Will you do the 70, 10, 20% where you have your 20% test split, 10% validation, and 70% for training set? Yes, what would you choose? I'm seeing some answers here. Some say what D. We're saying D. Okay, yeah, at first I thought about D, just randomly you expect D. That is what we do normally, the 70, 10, 20% split. This is what we do normally. However, the trick of this question here is, so as data scientists, if you know these things, you know the best approach to follow when training your models. Now, this is not just any data set. This is finance. This is sales record. Now, sales, there's one feature with sales record. Sales record has timestamp. So there's a store name and there's a timestamp. So the sales you make at night or during some certain seasons at different time of the year is different. You can't use that. It can't be the same prediction for what like this is season, right? This Christmas, this is a holiday season. The sales you make during holiday season will not be the same sales you make at the start of the year. All right, or during summer or so these are different seasons, especially with terms of sales data. So there's timestamp, very important. So in this case, if we do, let's say, if we use the random split, all right, we're going to be doing training on, we're going to ignore the timestamp, the chronology. Chronology tells us that there's past data, there's most recent data, and there's current data, right? So if we split the if we are predicting future sales of a new store, and sales data, of course, is time dependent, so we have to split it in a way that we're going to be training it on past data, validate it on recent data, and then test it on the most recent data. All right, so that's the way you should the approach you should follow. So this will prevent data leakage, whereby the model accidentally learns from the future. All right, so this gives you a more realistic estimate on how well the model will perform when predicting future sales. So the best approach to do what? Train it on what? Past data. Validate it on what? Most recent data or more recent data, and then validate test on most recent data. All right. So that is why we cannot use A. So A would do or train it on some stores and test on another store, which will not be the best approach. All right. So because it will ignore the time ordering problem. There is time-based forecasting problem here if you use the manual split or if you use any other splits. All right, so chronology is the most important thing here that takes into account the timestamp. All right, so that's it. Now, next question. Remove Right now, when a machine learning models perform well on training data but poorly on unseen data, now we should know this answer. Everyone, what's the answer? Read the question and put your answer on the chat. The machine learning models perform well on trained data but poorly on unseen data. Yes, yes, yes. Now, I want someone to explain that. Why is the answer B? Why did you say it's B? Yes, volunteer.
Okay, okay. I would like to say that the reason why it is overfitting is that the data on a graph is like saying, I'm going to use an example. It's like saying you bought a clothes that is very tight on your body. You can't actually share it with anybody. It's just you. So that's what I would reference it to, this training data.
Okay, okay. So usually whenever you see performs well on training data. So during training, it's just like in school, you memorize the answers, and then
Yeah.
on seeing during the exam, they give you a new question you've not seen, you fail it. So during training, you're getting 100%, you know? So performs well on training data, that's overfitting for you. So the model, in this case, the model has learned the data, the training data too well, memorized the noise, you know, and then it fails to generalize to new and unseen data. All right. So in this case, when you might see a question where you have a low training error, and then you have a high validation or test error. Or the question can come maybe during testing, there is high error in testing. You also know that is what fitting. Then what of underfitting? What's underfitting? In the case of underfitting, the model performs poorly on both training and what? Test data. All right. You might go for an interview as a machine learning engineer, and this is one of the questions to be asked. Just know it, all right? Um, then also when you're also training your models, you should know that um, when both during training and testing, your model is not even performing well. Of course, your model could be so simple that it's not able to understand the patterns in the data set. So it performs poorly on training and test data, which of course is not what the question is describing, but that's what underfitting means. So in the case where you have, I'm just explaining the concept just in case you meet it anywhere. Data leakage, maybe usually when you have artificially good performance on validation and test data, your validation and test data works well, but during but when you give it on scene data, it performs poorly too. So you could have data leakage in that sense, understand? So yeah, insufficient computational resources, that's completely out of the question, right? So next question, please read the next question and put the answer on the chart. Regularization techniques in machine learning helps machine learning to do what? What's the answer? I don't know which one. Have we typed the answer already? Okay, yeah, somebody said B. Yes. Any other answer? Yes, yes, yes. So we've said it before, reduce model complexity and prevent what? Overfitting. Now, next question. In the confusion matrix, what does the term true positive mean? I think I might think about the revised confusion matrix. Yes, we've seen that. So if this is your first time, please watch the videos go to the YouTube channel. It's on the chat here. You see lesson one, the one, lesson two, lesson one, the two. Watch those two videos. Now, what's the answer? Yes. Um, True positive. I want someone to explain the concept of true positive. Someone have not said anything before. Someone wants to volunteer, or do you want me to call names? Yes, anyone? Do you want to say something? Or Vanessa? Um, Veli, I don't know how to pronounce his name. Anyway, this will be example of nets, and yeah, this will be example of the net catching fish instead of rocks. So yes, anyone can talk, even if you've spoken before. Please, I need someone to just tell us what's true positive.
Okay, from what I understand, in reference to AI and in reference to what you said about AI giving a diagnostic. So, like saying the AI says it's true, and then in the patient, it's actually true. So that is true positive.
Very good, very good, very good. That's true positive. It's positive and it's true that this is positive, literally. So the example of the model correctly classified something as well positive. That's true positive. Good. No more, no less. Proceed. Yeah, hey, Kelechi, you're correct. That's true, positive. Yes. So, what does, okay, let's explain other concept. What of, we've seen true, positive. True, this is true. Actually, it is true, and the model predicts true. Then what of if it's false, and the model say is true? So someone doesn't have breast cancer, and the model says, the AI says the person has breast cancer. False, positive. Yes, good. So the model says it's positive, but it's what? It's false. Now, what if someone doesn't have um what is false negative? What is false negative? Yes, someone else to talk. Yes. False negative. Yes. Someone should, you can write it in the chat, or you can just unmute yourself and tell us what is false negative. AI says it's negative, but the data shows is that it's positive. False negative. Yes. So false negative. AI says it's negative, but it's positive. All right. Good. Let's proceed. Now look at this question. Read the question on the chart and then read the question. When evaluating a machine learning model, it's important to split data into training and testing sets. What is the purpose of testing sets? Yes. What is the purpose? To train the model on unseen data. Someone said to validate the model. We use validation sets to validate the model. To fine-tune the hyperparameter is not to fine-tune, to clean, to visualize. So training set to do what? Okay, no, sorry. Purpose of testing. Please, the question is, what is the purpose of testing? We're looking at the testing set here. Yes, to validate the model, do we have the option then? To train the model on seen data and generalize, to fine-tune, to clean and process data. The question looks simple, but it's kind of tricky, right? So what is the answer here? Of course, it's not to visualize distribution. It's not to clean and process the data. So to fine-tune the hyperparameters of the model, to train the model to unseen data. So the answer is most likely to be A. Do we agree? Did anyone disagree? We know it's not D, it's not C. So of course, the keyword here is unseen data. It's A. Test set should be used, but unseen what? Data. That's the keyword. Doing hyperparameter tuning, you can use it what? Multiple times. So the answer is what? A. Final answer, A. Next question. Yes. So yeah, so you can see the keyword, what the deciding factor was what? Unseen data and test set. All right, good. Next question is, now explain the concept of bias variance trade-off in machine learning. Who can do that? Do this for us. Yes. Favor, you want to say something? Who can explain the concept of bias variance trade-off? If you know what the concept is all about, bias, and you could help us in that light. Now let's look at bias refers to the model's ability to learn complex patterns. While variance refers to the sensitivity of random fluctuations in training data. There's a trade-off between high bias, underfitting, and overfitting, high variance. Now, bias is linked to model simplicity and underfitting. All right. Variance is linked to model sensitivity and what? The model, in this case, the model will be so sensitive, it's so complex that it understands the noise. Do you get? So you're talking about model sensitivity, and that's variance. Now, when we now talk of the bias variance trade-off, we are looking at you're trying to find a balance between a good fit between not having a model to do what underfit, and you one have to sacrifice for the other. All right, so that's the concept of the bias variance trade-off. So the answer here is A. I mean, I don't want to look at other ones. So this tells us what bias is, and all right. Any question at this point? I really want us to look at the lab for those that are having issues. And let's look at this question, final question, before we go to the lab. So what are some ethical considerations surrounding machine learning models? Yes, ethical considerations. Please put your answer in the chat. Ethical considerations. Yes, what are ethical considerations surrounding machine learning models? I will need more answers. Please, some people are not participating. There's no, please, there's no, just guess, put something. I mean, just type something. That's all. Okay. So when you're training machine learning models, you want to make sure that the models are not biased against certain group of people. Let's so there was a time that an AI was released for employment. Imagine AI decides employment, and then for software engineers, and then AI will not discover that the AI does not give, or the AI, once AI sees that the application is female, and then it just reduces the importance of that application because the applicant is female. Because the AI was trained, the data sets for software engineers has a lot of men, is already skewed towards men. All right, so imagine that kind of scenario. So you don't want the AI to be biased towards a certain group of people. Or probably your data set was not trained with, was trained with a certain group of people and wasn't trained with the other group of people. So imagine a self-driving cars, your self-driving car was trained with people of color, and then maybe during the testing, you now have this certain group of people, and the self-driving car is knocking them over. So you don't want your AI to be what biased towards a certain group of people, and which is very important. You want everybody to know how does this AI makes this decision. That's explainability, explainable AI and fairness. All right, it's a very important concept, very important. So it's very important it's a very important ethical consideration. Another ethical consideration is privacy concern. As we are using these models, are we giving out our sensitive data? Does AI using to train? It's still an issue with these our large language models. When you're using large language models, does it take your data? So these are ethical concerns, privacy concerns. Now we also have the explainable AI and accountability. Now, can we explain how this model arrive at decision? If AI is responsible for giving us jobs or giving us admissions at universities, can we explain how this AI arrive at this decision? Who is responsible for the outcome if AI denies you admission into university? or AI denies you a job, who is responsible? So we have the issue of what? Accountability. You can see the answer is what? D, all of the above. So all these ethical considerations have to be considered when building your model. Yeah, Gina, go on. Jotham. Yes?
Yeah, brilliant, sir. Yeah,
Yeah.
so on this topic, I think I wanted to, because at what level do we then consider this these ethical considerations? At what level do we consider? Is it at every, maybe let's, when we're training a model, when we're building a model, or you get, I mean, because I think recently I've learned that machine learning have different, this selected categories or something, where you get to train models, where you get to work with pre-trained models, right? And then where you get to what would I say now? We don't do much of fine tuning. There are cases where we don't do much of fine tuning. Maybe we're using already made APIs, right? So at what point do we consider these ethical concepts, right? That's what I'm saying now. I don't know if
Good,
I'm
very
making
good
sense here.
question. Good question. This consideration should be done at every stage from the inception of the idea. Like you want to build this model, this awesome model that will be giving people admission in school, or that will be giving this model you want to automate the job an AI that will be giving jobs, recommending jobs. From the concept, you don't want to people to be biased. You want to make sure that people data are used well. You want to be able to explain. So it should be considered at every stage. So even doing your data collection, you just know that you have to reach out to different groups of people. You just make sure to the more group of people you reach, the more diverse the data set is, the more better. So you can see, but when you have your wrong data, if your data is skewed towards one set, you've gotten it wrong from the onset. All right. So from the conception, you start considering all these ethical concerns. So at each stage, you'll be asking yourself that question. During fine tuning, you ask yourself those questions, right? Those are what you'll be testing, right? And even from your data collection, have you removed personal identifiable information from your data set? All right. So
Okay.
these are what you have to do, even from data cleaning. So and then
Uh,
you also checking the features you're using for your training. Do you have demography in your training such that after training the model will bias towards a group of people? So in that case, you might need to remove an entire demography so that your model doesn't know who is living in Ajegunle or who is living in San Francisco, because you
okay.
want the model to do or to work for all group of people, not just for people working in San Francisco or living in VI or Nairobi. All right. So
Okay.
these
So
are good. Go on.
that means for in cases of maybe custom training or pre-trained models where we get to fine tune, as well we get to work with data sets, we have to consider these things. For a model that's already been trained, like fully trained, and we don't get to do much of this maybe fine tuning or anything, we don't need to worry about this. We are going to assume that they've already considered all of these things, right?
Okay. For a model that's, of course, if a model that you did not train that you're using,
Yeah.
I mean, if you have option to use ABCD model and you find out that this model is biased, you're obliged to stop using it and to make that complaint, right? That this is not doing what it's supposed to do. All right, and then use a better model. So even if, yeah, so if you discover that this model, maybe you're using the API, I mean, you didn't train it, but even if it's open AI you're using, and then you discover that, I mean, this model, you give it this group of people and it says this, you give it this group of people, all right, you at that point in time, depending on what you're using it for, you can decide not to use it for that purpose because this is not
Bias.
conforming, yeah, to the ethical concerns.
Okay, sir.
So it's a
Okay,
moral
sir.
obligation actually. That's why it's ethical, right? Any other question, clarification, homework? So ideally, we are running out of time. So now, if this is your first time, we said join. The first thing you need to do is to join the Google Cloud Innovators. First things, join the Google Cloud Innovator and then start the track. Now, we don't have time, but let's see what we can do. Now, if you want to join the Google Cloud Innovators, let me do this again. Just go to Google, type Google Cloud Innovators. Simple. And then click on it. It will ask you to be what? Be a member. So be a member, and then once you confirm that you're a member, the next thing you need to do is go to Cloud Skill Boost. You want to go to Cloud Skill Boost. You're interested in skills of Google parts. It's part 17 we're interested in here. Please take note of this link in case you start looking for this machine learning engineer track. That's what you should start with. So this is skills of Google parts 17. Take note of it. www.skills.google/parts/17. Don't forget it. And then you start. So you're going to start with this. You can start with this. But this is the first lab. Take the course. Take this one. When you finish this, you start with this. Go on with this. Go on with this one. Go on with this one. All right. And then please, if you have any question, bring it to our WhatsApp group. Right, but let me just quickly open before the time runs out. So let me start this lab. Please drop the URL on the screen. Okay, my screen is blocked. Okay, let me go back. So this is it. I will drop this URL, please, for everyone. This is the course we have to take, please. The first one is you've seen how to be a no, this is not it. We've seen how to be Google Cloud Innovator. The Google Cloud Innovator will give you access to credits. Now, when you're here, when you're on Cloud Skill Boost, check your subscription. Make sure that you have go to subscriptions. You will see, no, not here, not here. This is for you to buy. You will see that you're on what? You can see the current subscription I'm on starter. All right. And if you're on this, make sure you're on this starter, claim the subscription. It will give you 35 credits every month. So that's the idea. So you keep getting 35 free credits for your cloud skill boost to take the labs every month. So this is it. That's what I'm using right now. I'm also using another subscription, but don't worry about it. This is a developer premium. Yeah, but it's different. So, but this will work for you. All right. The starter, this is what I'm asking you to claim if you join the Google Cloud Innovators program. All right. So there are other programs you can also join to get this one I'm getting, right? So by this moment, if you're also on Pro, you get this, and those that want to pay money can get this, You could pay this every month, and then you could, you could read more about it and know the benefits, all right? So this is it. So make sure you're here, you have this current starter pack, get it. And then when you now have it, you can now come to what? You search for the machine learning track, go to your dashboard, or go to parts, and search for the machine learning engineer. It's ML and data. You might have to find it. You might have to explore part and look for it. So, but I don't want to spend time looking for it. I think it's on the second. Yeah, good. It's on the second 77 tab. Yeah, so this is it. So you can see the other certification part. So this is it. part 17. And then let's do this lab, hands-on turn. So for the very first time, this is the very first time you're doing lab, and someone is asking what's the deadline. We did a study group. I mean, when you're ready, if you're is self-paced, there's a time limit for, okay, for the entire part, no, it's self-paced. You proceed as much as you can, right? But when you start the lab, you're given a time. So let me start this lab right now. So all I need to do is click on start lab. But then I've started the lab, and in the lab, you have instructions. It tells you what to do. So you just read this thing. It's telling you about Google Suite. What is Google Cloud? So this is Google Cloud. This labs gives us access to the Google Cloud console. All right. So we're going to be doing our experiment on Google Cloud itself. Google Cloud is is a cloud service, right? Where you have, just like someone's computer, we're using Google servers, Google computers, supercomputers, that gives us compute power, processing capabilities, right? And storage capabilities, compute. What else? It gives us there's a whole lot. There's load balancing. There's a whole lot you could do on the cloud. So, but in this case, we're going to be doing this on Google Cloud. And this training here, this training is a cloud skill boost itself. All right. Now, the first thing is let's go to Google Cloud. To access the Google Cloud is to open the Google Cloud console. Now, to do this, if I just click here, it will warn me, it will not allow me to even do that. Previously, it will allow you, but right now, because they don't want people to be charged. All right. They don't want to be charged on, if I open this and it allows you, it will be charged on my normal account. And my credit card is already on this account. So before I know it, I may click on something and I'll be charged without knowing it. So you want to make sure that I'm using this student account. So for each project, it creates an email for you immediately, a temporal email, user account for you. And it gives you a password and it gives you a project ID. If you copy these credentials right now, you can start using my lab. That's how, yes. If I give you this right now, you can copy it and start using it. All right, so you understand? So we are using the same cloud service. So it wants me to do what? Open this on what? Incognito window. So I will do what? Right click and do what? Open in new. I can actually open a new tab, but because I'm sharing a screen, let me do it in split view. All right, this is a new feature. So this allows us to see, you can see the new feature. Now, this is it. So I'll do what? I can log in with username, student, and then password. Next, password. All right. And then we're in, we're moving. All right, I understand that we are out of time right now. Well, so now this is the Google Cloud Console. This is not sandbox. It's not a playground. This is the same cloud service that is used by everyone on Google Cloud. So that is why you're giving a temporal account and giving the time limit to play on the real thing. All right. And from other Google Clouds that I've done, qualifications for voucher. Yes, some you've done. I mean, yeah, this is actually outside the timeline given us. All right. So officially, this timeline is supposed to end 31st of December, but we're not going to recover. Yeah, so don't worry about the certification voucher. That's why I said for now, we can always join another program where we'll have a certification voucher and a timeline. By that time, we already know this, have this knowledge on our head. It's just to write the certification, okay? If voucher is your problem. Right now, focus on getting the knowledge first. When you're done learning, for if any program comes out and you need a voucher to write the certification, then you jump on it and you're not learning again, you just want a voucher. You just jump on it, okay? That's my advice. So right now we are using the lab right now. So I'm on this console right now. It gives us, you have billing, identity access management, marketplace, you have different Google products, different cloud options, you know. Now, this thing can be confusing and overwhelming if you're a beginner, but let's keep it simple. So we have billing. This is for billing. Billing, each project has a billing account. All right. Right now, you see the student, this one is not linked to any billing because they're giving it to us free. But if you're doing it on your personal account, you must create a billing account. All right. So that's for billing. Then you have the identity access management. Yes, this is for the identity, the whole account, permissions to the account. So each account, you can decide to create a new account, give it permission, or for this existing account, you can expand the permission, right? Yes. So I will not be doing when you're using Cloud Skill Boost. Although I'm on the cloud, I will not. It is wrong for me to go and start creating an instance right now, a VM machine. I'll be penalized for doing that. I can do that right now, but I will not do that because if you do that, this lab does not allow me to, doesn't say I should create virtual machine. So if Google finds out that I'm creating a virtual machine, they would give me a warning. Virtual machine is like creating a new computer or enabling all these APIs right now. This does so when you have access to everything, please just do what the lab say you should do. So, but I'm just explaining these different, you can see the Vertex AI we saw in the, you can see it has, I'm not going to open it because the lab doesn't say so. And I don't know if enabling the API would be a breach of what is here. So, but then you can see the Vertex AI, there's a workbench where it has notebooks. You can do training, you can collect data set, it has feature stores, it has endpoints after training for deploying your models. It has the model registry. You can also monitor your training for retraining, it can send you alerts. So there's a whole lot here. There's cloud storage for bucket storage. You can store BigQuery, you can do analytical database here and a lot more. And there's a whole lot of security. Now, of course, the cloud platform, you have the um, platform as a service, you have the infrastructure as a service, you have the platform as a service, and then you have software as a service. So each of these fall under a category because it's a cloud service, right? At the point where you're using API, I mean, API is software as a service, or you're using Google Cloud. Um, if you're using when you're using um, Gmail, not Gmail, Google, what's the storage? Google Drive. You're using what? Software as a service. All right. Everything is built, it's still on Google Cloud, on the Google Cloud, but the application is free. Everything is, you don't have control, you just use the application. Right? Then when you now start selecting your database, your operating system, or you start looking at the platform as a service. When you now start creating your own VM machines, right? You're looking at infrastructure as a service. So there are different cloud offerings, all right? So I've spent a lot of time explaining just for absolute beginners to understand this. It might be overwhelming looking at this console at the moment, but then when you're going to see your project. Your project ID is always here, and then you have this intro part. All right. So good. So now let's see. This lab even assumes you've created a virtual machine. So you could still go to your Cloud Skill Boost and take this course if you want to, but you can still proceed without it. So at this point, the lab is just teaching you to read, telling you about credit. So for you to run the lab, you need credit, which is equivalent to $1 US, and then Yes. Now, if the lab has questions, this is just questions. In some labs, you dive into different instructions. So go ahead and do what? Test your knowledge. After reading all this, read it very well. Don't rush. You have time. And then let's answer the question. This builds a temporary environment in the cloud. If we click on Start button, what happens? It builds a temporary environment in the cloud. That's what we have here. So this will be the answer. All right. If you read it well, you know the answer. So we click. Now, when the timer reaches 00, you lose your temporal. Is it true or false? Please answer. My battery is running out. Okay. Yeah. True or false? When the timer reaches 0, where's the timer? See the timer here. When this timer reaches, you will lose temporal access to the cloud environment. True or false? That's true. Some lab have tracking, which scores your completion of. Yes, some labs, when you're doing it, it's increasing the score. We're going to see that, yes, this one has tracking too. Yeah, so true. And then in order to receive lab credits that has tracking, you must complete the required hands-on. Of course, true. You need to complete it as we are doing right now. We are completing the task to do what? To get the score. We have no score yet now at the moment, even though we've done all this, because we've not reached the checkpoint. Now, access to the cloud. Good. We've opened the console. We're in the console right now. And then we're logged in with our username and password, okay? And I'm rushing because of time. So now, let's try to understand this. Please take your time and read it when you're doing your own lab. Answer the following multiple questions to reinforce your understanding. What is not filled on the left plane? This is the left plane, right? This is it. What is not there? No, this is not what it means. I've left. See what you're looking at here. Sorry. Where's the left plane? Is referring to good. You have username, password, right? Are you seeing this? And then you have project ID was there. So that's what it's referring to. So where are we? Where are we? Good. Password. We saw password, right? We saw open console. We saw project ID. Did we see system admin? No, we did not see system. So the answer is system admin is not there. But project ID is there. You can see your project ID on the left pane. I don't know why I'm not seeing it here, but this was referring to this console username password. All right, seeing it, and then project ID is there somewhere. All right, so the username on the left, which resembles students, is true or false. So this is your identity, cloud identity access management identity. This is it. This is it. Yeah. Of course, the project. No, sorry. The account itself is the account itself is the can see students. Yeah, so that's it. True. Now you can view projects in the Google Cloud. All right. It will always tell you the project you're working on. So later on, make sure you're working on the right project. All right. So this is the project info. And I don't know. Let me click on this and see what that will tell me the same thing. Okay, yeah, see the project. And I just want to see if we bring out this part. Okay. So this is about the project. This is the project ID. And yeah. If you want to create a new project here, but we're not creating a new project. So project name, project number, you can view all projects. Yes, so follow this lab gradually. And then let's just answer these questions. Now, An organizing entity for anything you build with cloud. Yeah, so everything is arranged in projects, right? So it's not username. The cloud project is the organizing entity for anything you build in the cloud. It's just like the folder, general folder for everything you build in the cloud. All right, so this is it. And the quick lab resources are shared with all quick users, so you cannot delete or modify it. Yeah, this should be true. Yes, good. Because this is a resource, it is shared. You're not the only one using it. So you cannot just modify things or create a new storage bucket at will, All right. They'll penalize if you do that. Quick Start Research is a project where you run all your lab steps. Is the project, is this the project? Quick Lab, where you run all your lab steps. True or false? I just want to finish it so that we go. So true or false? This is it the project itself? I don't think it's a project. So let's say false. Yeah. The project itself is the Google Cloud project, which has a project name and project number, right? That's where you run everything. Quick Lab is this Google Skills is the Quick Lab itself. You can see this is the Quick Lab, and we are doing it. The real execution is here, done on this screen. Do you understand the difference now? This is the console, but this is the Quick Lab. It's not where we are running it. This is for us to check. This is where we are running it, right? So I can explain that. So this navigation, you have your active cloud shell. In some labs, you will be told to open this up. And yeah, we've seen the navigation menu. And yes, we've seen the identity access management where you can modify account, grant permission, add row. It's asking us to do something, to go to the navigation menu, grant access to this identifier. So we'll just copy it. So in this case, what you do is do what? Copy what they said you should do. And they say go to navigation menu. We go to navigation. They say we should go to what? Identity asset management and admin. This is it. Open identity access management. And then what do I do? They say we should do what? The next step is select row. These are the rows. Yeah, so these are, and then select row and assign. So click on what? Grant access, please. Follow step by step. Grant access. Add the principal. This new add principals. So this is a new principal we're adding. I just copy pasted. And then select row. The row should be what? Viewer. So assign the viewer role. You can say viewer. We select viewer role here. And then do what? Save. That's all. That's what the lab wants us to do. And then once we do that, it will ask us check. And this will only mark good because I've done this. Oh, it's not marked because maybe still granting access. I was too fast. You see, it worked right now. So these are challenges some may face. Just allow it, give it some time after doing the instruction and then check and come back. And then you can now continue with the lab. Quick offers quick access to platform services, dash, and also outlines offering. That should be in the navigation menu, yes. And then basic rules set at permission level unless, yeah, this should be true. Dash provides viewer permissions plus permission for actions, modify state. Viewer permissions plus permissions for actions than modify state. I didn't read this well. Dash provides all viewer permissions plus permissions for actions that modify states, such as changing existing resources. It should be beyond viewer. It should be an editor. Good, because when you say modifying existing resources, viewer can only view, right? So just use your head. And It also wants us to enable API. I mean, so when you do that, check and then, okay, let's enable API. Some people might be having challenge today. So navigation, it says go to navigation menu, API services library. Navigation menu. So let's say I'm confused again. I click on navigation menu. You say I should go to where? So I identity access management. So let me leave this place and then come back again. He said we should go to API and services. So API and services is here, and then click on library, and then under category, I should choose this category. I should choose dialogue API flow. If you don't see it, you can do a search, please. Anytime you don't see something, you can just do a search, and this will quickly bring it up for you. Yes, do a search and to bring it up for you. And then it says to do what? Click on it, enable this API. Some labs require APIs. If I'm working on Vertex AI right now, I will need to enable all the APIs that are required for Vertex AI. Now, this API requires us to do what? Build rich conversational applications. So once we do that, we enable. I've enabled it, right? And then you can see the button to disable to tell you that it's enabled already. And then the lab wants us to check our progress. And then we click what? Check. And when I click this score, we should do what? To change now to 100. And then the final question. When you start a lab, you need to enable API to in your project to start. Is it true or false, please? I want an answer. When we start the lab, did we enable API in the project to start working on Google Cloud? Is it what we did? True or false?
No.
No. So
False.
false. Very good. So we understand it. We are done with this lab right now. This is as simple as it is. So you follow instruction, do it on the console. All right. Some instruction may be complex. You have to come back, read again. If you get lost, start afresh. Just read in between lines. Type code on the console. Type code where necessary instead of copying and pasting. Very good approach. And yes, so that would help us. Please join the WhatsApp group if you're not there. Start the lab, share your progress on the group, and let us know how you're progressing. So next class, we're going to start with lesson 2. You're going to be receiving emails and invitation as you did today. Any question before we close? Thank you for your time, everyone that has been here to this point. Please, any question before we close? All right. So in absence of this, I would please make sure in the WhatsApp group, I will share this slide on the WhatsApp group because we are done with this. So we can have it, okay? And then we'll get ready for the next lecture on next week, Monday. See you next week. All right?
Okay.
Okay. Bye-bye.